Hi everyone. Chapter 1.2, Analyzing Graphs of Functions and Relations. Okay, we will talk about zeros, roots, symmetry, even function, odd function. Example 2, domain and range. Use the graph of f to find domain and range of the function. Okay, domain means all possible input values. Range means all possible output values. So usually X is input, Y is output. So when you look at this graph, to find the domain, you are looking for what's all possible input value. Input value, X is input. X-axis is horizontal axis. So domain is how far to the left to the how far to the right is graph covering. So as you can see, this arrow here on the left, arrow keeps going down, also keeps going to the left forever. So if you keep tracing this left hand, it will keep going to the left, 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 left forever. So forever to the left, how right can you go? What's the most right x value you can reach? Right here, 3. So it stops at 3. Where does it start from? Like forever to the left. Elegant way to say that is minus infinity. Forever to the left is minus infinity. Forever to the right, that's a positive infinity. So you go minus infinity to, where do you stop? At 3. That is a domain. Infinity or positive infinity or negative infinity, always go with a parenthesis. And 3 has a solid dot. Solid dot means inclusive. We want to include 3, you do bracket. Parenthesis, exclusive. You're not including that point. Bracket, you are including that point. So that's how you use interval notation. Or you might say x is less than or equal to 3. X is less than or equal to 3. That's interval notation. This is inequality. Whatever works for you. Range means how low to how high. So if you look at the graph, it's going down forever. So what's the lowest point the graph can reach? Forever to the down. The fancy way of saying that is minus infinity. What's the highest it can go? Right here. Right here or right here, it can go as high as a 2. So minus infinity to 2. So range, you can write that as minus infinity to 2. 2, you don't see a hole there. It's a solid curve, meaning it's a solid. So bracket. Infinity, always go with the parentheses. You could write this range as y is less than or equal to 2. Inequality, interval notation. Either way is okay. You do it. Pause the video, try to write the domain, try to write the range. Domain, minus 3, comma, infinity. What's the most left graph can reach? Right here at minus 3. But we have a hole, so minus 3 should have parentheses. You go to the right. Someone might say, well, this is empty dot, but it is covered by this hole. So we are okay at x equal to 1. Keep going to the right, this arrow here. Keep going to the right forever. So that's to infinity. Left to right. That's how you write domain. Range means how low the graph reaches, how low forever to the low, minus infinity to how high, minus 1, minus infinity to minus 1. Minus 1 has a hole, so we got parentheses. Okay, there's a gap. There's a nothing between. So that's why you're doing union, which is same as or. This is same as or. Here, or, what is this? It starts from 1, it ends at 1. So technically, you could have said 1, comma 1, bracket, bracket. That's how you say formally, and that they wrote like a one, just one of them in bracket. But this is a formal way to write 1 to 1, because right here, you start from here, you end up right here. Okay, find y-intercepts. Use the graph of the function following to approximate its y-intercept. Well, graph is provided. Finding y-intercept, very simple. Where does the graph hit y-axis? Right here. That's y-intercept, given graph, minus 1. Okay, y value is minus 1, done. Okay, then find the y-intercept algebraically. Okay, any y-intercept, finding algebraically, if you try to find the y-intercept, what do? Plug in 0 for x. You're trying to find the y-intercept, plug it in 0 for x. You're trying to find x-intercept, plug it in 0 for y. Okay, so plug it in 0 for x. So if you look at this equation here, g of x equal to absolute value of x plus 2 minus 3. G of x is same as y. That's same as y. So you're trying to find the y-intercept, plug 0 for x, plug 0 for x. You're going to plug it in 0 there, plug it in 0. So 0 plus 2 is 2, absolute value of 2 is 2 minus 3, y equal to minus 1, that is y-intercept, minus 1. That's how you find y-intercept algebraically. Okay, use the graph of f of x equal to x cubed minus x to approximate zeros. Okay, zeros are exactly same as x-intercept. Root, same thing. 0, x-intercept, do same thing. So use your graph to find the zeros, which is x-intercept. X-intercept means where does the graph hit x-axis? Right here, right here, right here. Minus 1, 0, 1, done. Then find its root zeros algebraically. Okay, algebraically, we did y-intercept algebraically. Well, I talked to you about how to find x-intercept. X-intercept, how do you find it? Plug it in 0 for y. Very simple. So if you look at this, f of x equal to x cubic minus x, this is y. F of x is y. Y equal to x cubic minus x. So to find the x-intercept, plug 0 for y. 0 equal to x cubic minus x. You need to solve for x. Do you see x as a cubic power? You are hoping to factor in common factor. Okay, what can you factor out from x cubed and x? X. So you factor out x. If you factor x out, you got x squared left. Factor x out from minus x, you got minus 1. Okay, some of you might say, well, I kind of forgot what you mean by factoring. Factoring means x cubic. Factor x out from x cubic means divide by x. So you have x times x times x divided by x. 1x is gone, so you end up with x squared. That's how we got this. Minus x, factor x out means divide by x. X cancels out, left over is minus 1. So that when you distribute this, x times x squared, you get match with this. X times minus 1, match with minus x. That's how you do factoring. We're not done yet. You have to keep factoring with this guy. So hopefully you remember this. A squared minus b squared formula is a plus b times a minus b formula. Well, if you don't remember, memorize it right now. That's the formula you will use very frequently. So 1 is the same as 1 square. 1 square. 1 is the same as 1 square. So if you look at it, that is exactly the same structure. X becomes A, 1 becomes B. You're just doing factoring using this formula. So it becomes x plus 1 times x minus 1 with a parenthesis. Factoring is done. Okay, this times parenthesis equal to 0 means this could be 0, this could be 0, this could be 0. So you let each factor equal to 0. That's 0. X plus 1 equal to 0. X minus 1 equal to 0. Solve for x. This one is already done. Solve for x. X equal to minus 1. Solve for x. X equal to 1. We got 3 answers here. This is how you solve algebraically. Okay. You do this. Pause it. You do it. Okay, so by looking at the graph, finding zeros, x-intercept is fairly simple. It's hitting x-axis right here, 1, 2, 3, 4, 5. Then find algebraically. Okay, so algebraically means what? Plug it in. This is 0 is same as y-intercept? No, x-intercept. 0 is the same as x-intercept. So you plug it in y is 0. So plug it in y is 0. Solve for x. Plus 3 plus 3. Getting rid of the root, square both sides. So square root and square, they cancel out. 3 square equal to 9. Minus 4, 5 equal to x. This is how you solve algebraically. Okay, there are 3 kinds of symmetry. This one is called symmetric over x-axis. Symmetric over x-axis. So when you fold against the x-axis, they are symmetric. This is called the symmetric over y-axis. So if you fold against this, they are matching each other. Okay, this is called the symmetric over origin. Symmetric over origin means top right corner, this portion, you can reflect over y-axis, reflect over x-axis, then they will match. Okay? So again, this is reflection over x-axis. This is a reflection over y-axis. This is a reflection over origin. Later slides will show you, we have a name for this function. We call that as an even function. We call this as an odd function. We don't have a name for this. Okay, another thing you need to pay attention here. Replacing y with minus y will produce exactly same equation. Why? As you can see here, anything above x-axis, there gotta be matching a coordinate downward. So their x values are exactly same. Y value would have different sign. So they are symmetric over x-axis. So if I give you an example, it will be something like this. If you happen to have, let's say, 3,2 as a point, then there will be another point 3, minus 2. So when you draw the graph, they will have matching symmetric over x-axis. So you will have exactly same x values. Y value will be exactly same except they are different sign. That's what they meant. Replace y with the minus y, you will produce exactly the same equation. For same logic, if you have symmetric over y-axis, you will have equation replacing x with the minus x would replace that replacement will result in exactly the same equation. So here, x changes sign, y changes sign. So there gotta be matching point satisfying that condition. What does that mean? Replace x with minus x, replace y with minus y, that will produce equal equation. That's a proof of other function. Okay, testing for symmetry. Use the graph of the equation to test for symmetry with respect to x-axis, y-axis, and origin. Very simple. By looking at the graph, very simple. You're just asking, is that symmetry over x-axis, y-axis, or origin, over origin? So if you look at it, you can tell it's symmetry over y-axis. So answer is y-axis. Okay, support the answer algebraically. Yeah, that's not that simple by looking at it. So if you look at this chart, so symmetric over y-axis, how do we algebraically check that? Replace x with minus x. So if you look at the equation, y equal to x squared plus 2, that is original. So you're replacing x with minus x. Here's the thing you have to be careful. You want to replace that with a parenthesis. The x is the one you will have to replace. So instead of writing x, write parenthesis. So write down minus x, you're replacing x with minus x. Since you have a parenthesis square, minus disappears. So if you evaluate that, it becomes this. So we replace x with minus x. Look at this and look at this. We have exactly the same equation. So support the answer algebraically. This is how you support it. Equal each other. So that's even. So symmetry over y-axis. Okay, pause the video. Try this. So use the graph of the equation xy equal to minus x, test for symmetry. Okay, so you should know just by looking at the graph, that should be symmetric of origin, which is other function. How do you know? This top left corner, this graph, you can reflect over y-axis, which is going to be something like this. Then you're going to reflect over x-axis, so they're going to match. So you should know over origin by looking at the graph, then support the answer algebraically. Okay, how do we support that answer algebraically? Replace x with minus x, replace y with minus y. If the equation is exactly the same, then that's how you do it. You're going to replace x, you're going to replace y. Replace x with what? Minus x. Replace y with what? Minus y. Well, minus times minus is positive, so it becomes xy equal to minus 6. This is exactly same each other. So we say symmetric of origin. That's the answer.